Good afternoon. Welcome, everyone. Thanks for joining today. I'm Amy, your host from Unidesk. We've got a real hot topic for you today. We are focused 100% on storage, VDI's biggest headache. We're lucky to have Stephen Goodson, Network Administrator from William Woods University with us, as well as Senior Solution Architect Rob Zalewski from Unidesk. All right, to start off the session, here's Stephen. Stephen, take it away.
Good afternoon, everyone. This first slide is just kind of what UIT's mission here is at William Woods University. We are a private university. We traditionally have about 1,500 plus graduate and adult study students. We house about 900 traditional undergraduate students. We have roughly 350 plus faculty and staff. We're a liberal arts and professions-oriented university offering degrees in business, administration, MIS, equestrian science, education, and communication. Initially, we've completed our Phase 1 deployment last summer. We started out hardware side with a Dell PS6510 Equalogic SAN. We had two HP DL380 G7s with FiOS cards installed locally and about 100 Weiss P20 clients. We're a VMware shop. We're using version 4.1, VMware View 4.6. Unidesk 1.4, and we're a Windows 7. This is kind of what our infrastructure looks like between the VMware side and the Unidesk side. Our planned deployment was going to be in 3 phases. We completed Phase 1, which was to virtualize all our campus labs with non-persistent virtual desktops and Weiss P20 clients. Phase 2, we had planned on extending all our campus labs and application pools for student use in the cloud, anytime, anywhere. And then Phase 3 was to virtualize and extend all faculty and staff PCs to the cloud. Well, this is actually what happened in deployment. We completed Phase 1, and then Phase 2 and Phase 3 just melded together into one. So Phase 2 we're conducting this summer was to extend all the campus labs and application pools to the students and begin virtualization of faculty and staff PCs. The reason they basically melded together was the overall success of Phase 1 basically resulted in the acceleration of our deployment due to our customers' acceptance and their actual demand for virtual desktops, which is a good thing. So when we initially started our Phase 2 deployment, we had some discovery questions that we asked ourselves. Are we ready for Phase 2? Is our infrastructure ready to expand to 500 plus desktops? How can we increase the performance of our customers' desktops? Where were the bottlenecks in our current VDI deployment? And how can we simplify the administration of our current infrastructure? Most of the answers to those questions revolved around storage. So we had the need to migrate our existing infrastructure to a new storage solution. Our existing Dell Equalogic SAN has been in production for several years. We didn't really have the space to do a 500 desktop deployment on it for the Phase 2 rollout. The performance with Equalogic was good, but not what I would consider great. And we had the opportunity to look at alternate solutions. So the objectives for our proof of concept was to research and determine environment criteria and vendor absolute proof of concept requirements. The only absolute requirement we had was the vendor had to supply loaner equipment for testing. Determine which vendor storage and solutions are available in the VDI space. Everyone's probably familiar with this, lots of research. We discussed with our peers, and we contacted our existing vendors. Select vendors that meet your proof of concept requirements and make initial contact. Making the initial contact really did save us a significant amount of time. Some of the vendors we contacted once we described our environment basically told us their solution wouldn't really be a good fit. A lot of this revolved around linked clones. Schedule the on-site vendor proof of concept and evaluate and score the solution. Sounded simple. Here's what kind of happened in the real world as we started going through the process. The reality of VDI storage solutions is deep and wide. There's a tremendous amount of brand new startups. Some people are in the mid-range. They've been around for a couple of years. And then, what I would consider the giants or the traditional people offering storage. At this point, there was no room for to fail. We had to continue our current success and improve our customers' experience. Your end user's VDI experience is really what matters. That's really the number one thing. So we had to be successful. We really can't have anything less, or we kind of take a couple of steps back and have to fight to get the momentum going again. I'm overloaded and having second thoughts about this. Looking at all these vendors and talking to all these engineers, I really had to take a step back, just take a deep breath and relax. It was overwhelming at times. The safe solution versus thinking outside the box. Vendor loyalty may not serve you best. Think about the new solutions. I would highly recommend it. A lot of these new companies have built their storage from the ground up specifically for VDI. One thing I'll note and make you aware of that some of these solutions may be contentious for your storage administrators, just in the fact that there really is no administration to it. It's putting it in the rack, setting it up, and you're done. The last thing was revise your solution criteria as needed. That happened several times for us. Basically, when we started looking at the field for our VDI storage options, we had about 4 choices. Traditional spinning disks, which everyone's probably familiar with, all flash-based arrays, hybrid arrays, which were basically a mix of SAS drives and flash, and local storage. Doing calculations for our environment to determine what we needed and then what we actually saw in testing. Unidesk does provide a tool that allows you to calculate the IOPS based on your estimated virtual machine load. What we found in our environment was the highest latency is always at the host. The disk storage and network latency is almost always less than a millisecond, but you will see spikes. One thing I'll note here too, your network infrastructure has to be solid. VDI is just very unforgiving if you have any underlying network issues. Reboots, rebicks, and boot storms will generate the most IOPS in your environment and always shows more reads than writes. So we have about 90% reads and about 10% writes. At boot, we average about 150 IOPS per VM, total reads and writes. It is a very read-intensive process. In production, our persistent desktops average about 30 IOPS per VM. Our non-persistent desktops average about 23 IOPS per VM. The read-write ratio that we're seeing is about 50-50, with our spikes occurring more on the read. Our environment's a little bit different. We do folder redirection, so some of the actual writes aren't happening to the VM, but to our Ecologic SAN. This may be the result of the 50-50. Calculations for space requirement. Unidesk also provides a tool to calculate storage requirements based on your environment needs. Be aware that additional space savings may be obtained through your storage vendor's features. So we save a tremendous amount of space through deduplication and compression. Testing. Recognize the challenges in your environment. Make sure you're ready to test and give yourself the time to do so. It's not really a process I would recommend rushing, or you're definitely going to miss things. Keep your testing the same across all platforms. We wanted to do an apples-to-apples comparison. Some configuration differences are to be expected, but the testing really should be equivalent. The biggest differences we had between the vendors were really just the method of connectivity of the network or their file system architecture. Determine what configuration or performance issues are acceptable in your environment. It's really going to be dependent on your environment and what you feel is acceptable or not. Allow your vendors to respond to issues and comparison differences within an acceptable time frame, of course, and you may have misconfigured something. So oftentimes if testing results had a large difference, I would actually contact the vendor and bring it up to see, what may be causing that, or is that just par for the course. When we tested, we used iometer tools. However, we really focused on results of real-world testing. So we populated massive amounts of machines, conducted rebicks, boot storms, mash machine creation, populating cache points, but probably most importantly, we had the customers actually test the desktops. We had them take it out for a spin and work with it for a week and let us know how they felt about the desktop. Our selection criteria that we graded all of the vendors on were obviously desktop performance, probably one of the most important ones. And this was from a customer's perspective, an end user's perspective. Ease of installation, ease of configuration and administration, the customization set for the device. What was really probably the second most important thing for us was the feature set offered by the vendor. So we looked closely at deduplication and replication, compression, disk alignment, and what sort of reporting and statistics we could get from the storage. Another extremely important one that came up, but I didn't grade too hard against it, was being VM aware. Most of the vendors out there will give you these statistics with the storage as a whole, but a few vendors actually give you the ability to monitor IOPS, throughput, and latency at the individual VM level. This is a huge benefit when you're troubleshooting. When you have an end user call up and say, my desktop is slow, it gives you a central point to look and at least rule out your storage right off the bat. VAAI certification for those people that may be VMware shops. Of course, the vendor support, we demand good support. It has to really be top-notch and responsive. So we tested the support with all the vendors, created problems, or just called them up on the phone. So documentation's a big thing. It was night and day. We had some vendors that had no documentation accessible from anywhere, and others that had thorough documentation. So when all was said and done, we scored our results. So 0 was they didn't meet the expectations of our criteria. 1, they met the expectation, or 2, they exceeded the expectation. So we had 5 vendors. We scored them and came up with the results of the scores and selected our vendor based on that. Deployment. So basically we ensured the integrity of the selected solution in the infrastructure. We then upgraded and migrated VMware and our Unidesk solutions. So after setting up the storage, configuring it, making sure it was solid, we went ahead and configured the data store in VMware, and then we began the VMware and Unidesk upgrade and migration. It really was textbook. I didn't have any issues whatsoever. It went very smoothly. I was almost worried, but we upgraded to ESXi 5, we upgraded to View 5, and Unidesk 1.6.2. After we upgraded the software and migrated our VMware View servers over to the new storage, we powered off all our VMs, configured the Unidesk management appliance for the new data store. Then we migrated the Unidesk management server, the master cache point, and all our secondary cache points and virtual machines to the new data store. We then powered the infrastructure back up and said a couple of prayers, confirmed the settings, make sure everything was good. We did implement some changes at this time to our Unidesk design. Just some things that we kind of didn't follow best practices with in phase 1. This was a good time for us to get those kind of resolved, and we took a deep breath and we were finished. Everything from front to start, when we started the proof of concept to the end of deployment, took us 5 months. Phase 2 deployment, we now have a new storage stand. We're currently using 4 DL380 G7s for hosts. We had an additional 100 WISE-P20 clients. And of course, I kind of already went over the software and where we're at with those versions. And that was it from start to finish.
Great. Thanks, Stephen. Hi, everyone. This is Rob Zalowski. I'm a solution architect at Unidesk. So, storage is one of the more difficult aspects of VDI, and mainly because storage for VDI is a bit different. But what we can talk about in the next set of slides is, from a capacity standpoint, how much will you require? We're going to look at this really from a Unidesk standpoint, but we'll compare a little bit to some of the other products if you do full clones and how that might work. We'll look at kind of type of storage. We're not really going to talk brands. We're going to talk types. So some of the stuff that Stephen already talked about, the idea of flash, do I use local storage, do I use SAN storage, et cetera. What about boot storms, and how do I approach my architecture based on that? And I have some ideas there, things that will help. IOPS, which everyone is certainly concerned with. Quite a while ago when VDI started, people didn't worry so much about IOPS, but I think they learned very quickly that it's a big issue and something you have to tackle when you design your storage, scalability, et cetera. So we'll jump into it. A couple things to think about where VDI is different. The first thing, I think, is that top bullet. VDI is very different from server virtualization in this regard, and what you're going to see is 50 to 80% random writes with VDI. Normally, reads are much higher when you're talking about server virtualization than writes. And the reason the writes are so high with VDI is because there's an awful amount of caching that goes on a desktop, and not only everything that's written, but everything that's cached gets into a write, so you'll see lots of write. And the hard part there is that storage arrays, ever since they were invented, were not optimized for write. Right? There's only so much they can do on the write side. There are definitely some newer, more interesting technologies that help there, but that's the real issue. So, what about IOPS and how do you handle IOPS? And we'll talk a little bit, as Stephen did. He came up with a good way to see, well, what do we need for IOPS? And I have another slide on that. But if you look at most of the vendors and their pages, they talk about kind of the light, medium, and heavy users and the number of IOPS that you would see from those. And in talking to customers, and we have a significant number of customers, and I always talk to them if I can about what they see out there. We do have certainly some customers where the majority of their users are light users, and you see 4 to 5 IOPS average, right? And it's important to differentiate between average and peak, medium and heavy, and there'll be some mix of that you have to account for. But just using a model where you take light, medium, and heavy, and you try to say what your users are from that, is not really going to give you the answer. So we'll hit that in another slide. But if you look at it and you said, I do have, for each host, I have 50 medium users, in the mix that I'm going to have, then I would need somewhere in the neighborhood of 400 to 500 sustained IOPS. And that doesn't count peaks, it's just sustained. We'll talk about that a bit. What would that mean from a drive set? Well, if you're just talking about drives, and the next page we'll talk about how many IOPS you get per drive, but you're talking about 4 to 5 drives per host for a read-write ratio of 40 to 60 without RAID, and maybe even 8 to 10 drives per host with a 40 to 60 ratio of read-writes with RAID 5, because there's a big penalty for RAID. So we'll get into that a little bit, things to think about and why it's hard. What about boot and login storms? Well, of course, that makes, if you have those, that'll make those numbers even higher. So you have to factor in, how can I get kind of some instantaneous headroom on top of that average? And in reality, you really need to look at, if I can take my mean, what are my standard deviations from that? I probably need to be able to burst to 2 to 3 standard deviations above that. It's a little technical. I actually have a reference for you to help in your mind figure out how to calculate that in the future. But let's first look at understanding, if I'm just talking about drives and I'm talking about IOPS for drives, what does that mean? If you look at the average IOPS for just standard drives of different types, you can see that in general they're relatively low. If I'm looking at a SATA drive, I'm probably talking about somewhere in the neighborhood of 75 or less IOPS per drive. A 10K SAS drive, a bit more than that, almost twice that, 125-ish. And then a 15K SAS drive, upwards of 175 IOPS per drive. But again, remember, if you're talking 4 or 5 or 1,000 IOPS per host, that's a lot of drives to think about. Then there's the impact of RAID, right? So if you do RAID 0, there's no impact, right? You get the full IOPS speed. If you do RAID 1, it cuts in half. RAID 5, it cuts in a quarter. And RAID 6, for writes, you're getting that much less. So you can see that writes are really where the pain is, but we discussed on the slide up here, right, that writes can be 50 to 80% of what you're trying to handle. So I'm going to flash some references up here. These are people talking about ways to calculate IOPS, et cetera. What I think the most interesting things on here for you to look at, we have published an IOPS calculator, which helps you do some relatively simple IOPS calculations based on your environment. And you can use it to get an idea of what you might need, though it's not real world. If you go to brianmadden.com, Ruben Sprout just created a very interesting article out there on flash storage and flash environments, which I think everyone should read if you're attending this. And I think the most important reference on this page is also on brianmadden.com, and the link was too long, so I didn't put it. But if you search for Daniel Beveridge, Applied Math for VDI Design, he did a Briforum talk in 2011 that goes into the math around calculating IOPS, and it's actually quite good. I think everyone should look at that. So what about boot and login storms? And it can be significant, but remember, it's only significant if you're booting or logging in a lot, right? So the boot storms are the worst because they're moving the most I/O as a machine boots. If you don't shut your machines down, right, and you don't turn them on when the users log in, then you don't have a boot storm because it's running at steady state. So I'm a big fan of not actually shutting down the machines, and therefore I don't have the boot storm for that. Certainly you'll have to, with Unidesk, reboot the machines when they get rebuilt, and that'll actually reset Windows and do those things that you want, but you won't have to deal with that on a persistent basis. That's normally happens on non-persistent desktops because they reboot all the time to reset. So if you're using persistent desktops, you'll have less of a problem with boot. Login isn't as big an issue, I don't think, as boot storms, right? So I think, and boot storms at least, as that second bullet point talks about, are 90% read. And SAN arrays and local SANs cache and handle read better than they do write, so the penalty is not quite as big as it could be. All right, but what everyone wants to know is how many IOPS do I need and how do I buy them? And quite frankly, unfortunately, there's really no way for, me, say, as a solution architect, to tell you ahead of time what you're going to need. I can tell you what most customers seem to go out and buy, kind of thing, but I can't tell you exactly the IOPS you'll need because every application and every usage pattern at a company is different. Some applications will certainly generate more IOPS if they're used more. And the more your users work on their computers versus not working, et cetera, or let's say, you roll out 1,000 desktops and you're a university, but really only 200 or 300 of them are used at any one time, you'll have a much different I/O usage pattern than some others might have if 800 of those people are working steady state all the time. So the best way to figure out what you need for IOPS is to actually calculate it. One way to do that is to take tools and run those tools on your current physical systems and try to find out what you're using in the physical world, expecting that it'll be pretty similar in the virtual world, and it will probably be similar. There are tools out there, and you could certainly use perfmon, although you'll have to do a lot more work if you use perfmon compared to something like Liquidware Labs or Lakeside Computers tools that gather information. But what you'll get from that at least is a good idea of what your current desktops are doing from an I/O perspective. And you can do it by taking a representative number of desktops and just look. Just remember that what you won't be able to do is you won't be able to align the times very well to be able to find out peaks and whether the peaks peak together or not, which is one of the issues you'll have. If you can do the number 2 approach there, you can actually then capture the peaks together, and it's a better way to do it. So if you can run a real-world POC where you set up, say, a host with 50 desktops of the types of users that you're trying to roll out, and you have them all use the system all at the same time, all that is a lot to get done, but if you can do that, then you can capture statistics from that and get a very good idea of what your usage patterns would be. That would certainly be the best way to go about finding out what your I/O load would be. Now, just back to this, if you're going to do a substantial number of VDI desktops, you're going to have a substantial I/O load. This becomes less important, and you know that you'll need some type of way to accelerate the storage based on that. But I have a slide on that a little later. Okay. How does Unidesk help with both I/O and storage capacity? We do some things at Unidesk, and I didn't want to get into a big, long discussion of how Unidesk works, so if you're not sure how it works, we have a normal weekly webinar series that you can get on and really come in and find out how our technology works. But at a basic level, we do pre-deduplication of software. So we deploy what we call shared layers to desktops, and we have a cache point on a host. Within the cache point, we store the files for the shared layers, like the operating system layers and any IT deployed applications, just once per desktop. So all the desktops on that host will use that one set of files. And let's say there's 50 or 60 desktops on a host. They're all going to use the same files for Windows 7 and for Office and for antivirus, which will give you an incredible decrease in the amount of storage that you're deploying for those hosts, compared with if you were doing persistent desktops, and that's a key on any other technology. So the normal way to do a persistent desktop is to deploy full clone and put the software on the full clone, and you're going to use a lot of storage. This dedupes compared to that. This is pretty similar in technology to something like a link clone, where many desktops are using the clone, except we're doing it for both the software and the OS. Because we're using that one set of files, what you find is that our data pattern minimizes IOPS and hybrid SAN arrays. because we can put almost the entire OS into hot blocks on that SAN so that they're all delivered out of hot blocks, and you barely have any latency from the SAN in that regard. And then because of both of those things together, you can probably get 4 times as many desktops on a particular array as you would get if you were doing full clone desktops. Another thing to think about, kind of what I mentioned before, is if you're using persistent desktops and you keep them running all the time, you're not going to get the same boot storms that you would get if you're using a non-persistent model where you shut desktops down. If desktops are running, they don't have to boot up, and you don't get the I/O associated with the boot up. So it's more of a steady state. VMware is very good at sharing memory. It's very good at controlling the processor, so it's not really as big a deal to keep them running as it is, quite frankly, to shut them down and bring them up again. So one of the questions that we had from several people was, if I'm using Unidesk, how can I calculate the amount of capacity I'll need? And we have a calculator to do that, and one of the reasons we have the calculator is that there's lots of different types of storage within a Unidesk environment. So I wanted to go over the different types of storage and then take the opportunity to use the calculator to compare what would it be like if we use Unidesk in a typical environment versus doing a persistent full clone deployment. So I took our calculator for storage, and I created 3 different categories of user: a knowledge worker, a developer, and a task worker, because they all use storage in a slightly different way. And if you look at our calculator at the top there, the first thing that you see is how much memory is there on a desktop. That's very important because VMware sets up swap for the amount of memory you have, and it uses storage to do that. We have to account for that. So you'll see how much memory and what size page file are going to be part of that, and therefore how much vSwap space are we going to use for that. The next thing we define is a quota of space for the user. At Unidesk, you create a quota for how much open space a user has to install into on a persistent desktop. And you can see here I've given a normal user 5 gigabytes of storage space, so that's a kind of a working set for them. They can install some programs if they're allowed to, and they have enough room to download files from the internet, etc. A developer probably installs a lot more, so I give them 20 gigabytes instead of 5, whereas a task worker really doesn't install anything. They just use programs, and they only have 3 gigabytes in this model. The next line in that says number of days of snapshots retained. So I've done a few things here. In this model, I'm showing apples to apples to a full clone desktop. They don't have snapshots, so I haven't shown it here. But in the next slide, I'll show you I added in snapshots and backups, and we'll see how much that changes the storage model. But for us, if you're going to do, we have a feature that lets you recover desktops back to snapshot levels, and you define a number of days you want to keep, and we assume that you'll use around 15% of your storage a day for snapshots, so we want to calculate that and have room for that in the model. Again, here it's 0, but I'll show it to you a little later without 0. How much shared layer space am I going to define per cache point? So I defined more for the knowledge worker because I think IT is going to package most of their apps and they'll deliver them. I said 125 gigabytes for those guys. A little less for developers because they deploy a lot of their own applications, so I made it 100 gig, and even less for task workers because they don't have as many applications, so I left 80 gig for that shared place. The next line is backups. If at Unidesk we have backups of the personalization layer, they require a snapshot which takes storage space. And we have to allocate that here. I've made that 0, again, for apples to apples, but I'll show you the difference in the models on the next slide. And then basically define that I have 50 desktops in each of these cache points, right? So 50 for knowledge workers, 50 for developers, and 50 for task workers. And what you see at the bottom is we have 2 types of storage at Unidesk. We have what we call cache point storage, which is storage that needs to be high speed. It's where the layers and the personalization layer go for a desktop. And then we have boot storage, which is a drive built for each desktop that boots drivers and things and has the page file but isn't used that often after that. And what you can see here is the recommendations for the size for those. For a knowledge worker, for the CP is 480 gigabytes, right? And the boot files of 200 gigabytes for a total of 680. For the developer, it was much higher because of that 20 gigabytes per desktop, right? It's 1.2 terabytes about and 1.5 total. And then for the task worker, much smaller. It's really only about 400 gig total. So what we're really doing is defining each part of the storage that you'll use, estimating that this is actually a worst case. For instance, the personalization layers are thin provisions. You don't usually use 100% of those, so this is the most you would use in that environment. So what I wanted to do on the next page was compare those numbers to what would it be if it was a full clone environment. So for a knowledge worker, right, for a Windows 7 machine, which is all this is based on, and a full clone would be, at VMware's recommendations, about 34 gigabytes for the full clone. And the required storage for that would be about 1.7 terabytes. For the developer, it's about 45 gigabytes per desktop, or 2.2 terabytes, and et cetera. Then what I've said is, what if we have 3 cache points worth of knowledge workers, 1 cache point worth of developers, and 5 cache points worth of task workers? What would we see for numbers? And what you would see there really is that the total required storage for full clones is about 13.5 terabytes. The apples to Unidesk would be 6 terabytes, right? So that's a 7 terabyte difference. If we add in 4 days of snapshots, remember I was saying I wasn't showing that, but I'd show it later, Unidesk goes up to wanting to use 7.6 terabytes. And then if you add in 4 days of snapshots plus UEP backups, you're up to 8.8 terabytes. So what I always think is I expect you to use those things. I would expect with Unidesk you'd use 8.8 terabytes, but you'd still be saving significant amount of storage from a capacity standpoint back to that original full clone model for persistent desktops. Okay. Points to remember, things, what should you get out of this? My first point there that I think is important is don't rule out local storage. We have lots of customers that do local storage either with SSD or a normal SAS array within their hosts. It works fantastic for non-persistent desktops if you think about it. You get redundancy through having multiple hosts. You don't necessarily need redundancy within a particular host. You can have your pools create the redundancy across desktops. You can still do persistent desktops on local storage. You just have to do, for us, persistent desktop backups to make sure that you can recover those desktops. Plus, you need to have some type of recovery desktop on another host if you had a host fail. So, depending on your SLAs with your customers, to save the money that you save having local storage, which is about a factor of 10, right? It's about 10 times cheaper to have high-quality local storage. You could just have backups and recovery desktops on another host. If you have a host failure, you give somebody a generic recovery desktop. It has most of the apps they use, but not all of them. And then you take a day and you recover their storage from their host and get it working again. That could be acceptable based on the SLAs that you have with your customers. You have to decide. One neat thing about local storage is it distributes the I/O to the host, and you're not centralizing all the I/O, so it's easier to have more I/O as you distribute it on each host. One really interesting way to think about that is using something like an enterprise MLC SSD, something like an OCC Vertex. They come in approximately 500 gig form factors. They get about 38,000 IOPS. So remember our IOP picture for disk drives. You would need an awful lot of disk drives to get 38,000 write IOPS. And it costs, in the neighborhood, and I just looked it up on Amazon, of about $700 or $800 for that. So, certainly you're going to save an enormous amount of storage if you use 1 or 2 of those cards in each of your hosts to supply your desktops, and then you do backups. Or if you're doing non-persistent desktops, you might not even need the backups. If you're going to do a lot of desktops, and what's a lot mean? Well, let's say 250 or more, think about the local option or hybrid storage. You have to do something to accelerate writes. You can see writes are very important. If you are not accelerating writes through some technology, you need an awful lot of disks, right? We kind of went through that. So look at the technologies that can accelerate writes. Talk to your vendors about your write needs, whichever vendors you're talking to, and find out how they expect to accelerate writes. A lot of the SAN technologies don't really accelerate writes. They use a lot of spindles to handle that. Some of the SAN operating systems are better than others at writing and having speed for writes in the way that they work. But you should talk to them, and VDI is different. They know it, and talk about how they can handle your write load for whatever you think it's going to be. But definitely if you're going to do a significant implementation, you need something that accelerates writes, whether that's some type of SSD hybrid, a special operating system that does it, or some other way. There's a bunch of ways that vendors do it. Right? And then think about Unidesk. We have some great advantages with that. One is we support local storage. You can use local storage for persistent or non-persistent desktops. We have great savings in capacity, which makes it easier to use something like a all-flash SSD-based SAN if you want, because you're not using as much storage underneath that. We have lower I/O requirements because we cache reads and we make the reads hot for hot blocks. And again, local or SAN. We match well with SAN hybrids, again, because of that smaller number of files used by a large number of desktops. We have integrated backup with our solution so that you don't have, you have an automated way to back up all the desktops and a way to recover them, especially if you use local storage and need to do that. We're a bit easier to use, certainly, than link clones or PVS from the management of the OS standpoint, and we're easier to use by far for management of the apps, too, compared to app virtualization, et cetera. We support persistent and non-persistent models, and then we eliminate the need for roaming profiles and profile management, as you'd see. So from a technical standpoint, that's where we are.
Okay, great. And that's all the time we have for today. A special thank you to today's presenters. On behalf of Unidesk, thank you for attending.